Welcome, people of physics, to the tutorial on problem number 67. This is a blue problem, so if you are confused, I do not blame you. Alright, now I'm going to help you figure this out, so let's take a look at the problem. Alright, problem 67 asks us, a stuntman is standing on a branch 3 meters above the level of a saddle he plans to jump to. The saddle is attached to a horse moving at a constant speed of 10 meters per second. The problem wants to know A, how far away must the horse be when the stuntman makes his move, and B, how long is the stuntman in the air? To make this problem a little bit easier, we're going to do this backwards. We're going to start by figuring out how long he's in the air, and then use that to figure out how far away the horse is going to be. Alright, so as always, the first thing we're going to do is draw a picture. So, there's our tree. Beautiful little tree there. Now, we need a stuntman. Here's our beautiful, beautiful stuntman. Now the next things we're going to do is look for our givens. So the first thing we're given is that the stuntman is 3 meters above the level of the saddle. The second thing we know is that he starts out with no velocity. He's standing in a tree. And the third thing we know, and this might confuse some people, is his acceleration. Because gravity is always constant, which means he's accelerating at negative 9.8 meters per second squared all the time. The next thing we want to figure out is which equation we're going to use. Now, Mr. Greenberg gave you a handy-dandy little sheet with 4 equations. So take a look at that one and see if you can figure out which one we're going to use. Alright, did you figure it out? The equation we're going to use is the third one on the sheet. Because we know his delta x, we know his initial velocity, and we know his acceleration. We do not know his final velocity. So we need an equation that does not use final velocity. And that third equation is our man. So now let's take a look at this equation, because we're solving for time, right? So let's plug in our variables and see what we can find out for time. Alright, so here is our equation with our variables plugged in. We've plugged in 3 meters as his delta x, we've plugged in 0 meters per second as his initial velocity, and we've plugged in negative 9.8 meters per second squared as his acceleration due to gravity. So now let's take a look at each separate part of the equation and simplify it. The first part of the equation, 0 meters per second times t, is 0, because anything times 0 is 0. So after that, we're left with only the other part of the equation, 1/2 of negative 9.8 meters per second squared times t squared. 1/2 of negative 9.8 meters per second squared is negative 4.9 meters per second squared, as you can see in our second simplified equation. Now to get t, we move the negative 4.9 meters per second squared over to the left side of the equation by dividing everything by negative 4.9 meters per second squared. And then we take the square root. We take the square root because we're looking for t, and the variable we have right now is t squared, as you can see in the second equation. Now, some of you are probably wondering why in the third equation 3 meters has been changed to negative 3 meters. I left it as 3 meters in the beginning because that's what we are given by the book. However, since he is falling, he is moving in the negative direction. And this negative is going to be crucial to cancel out his negative acceleration due to gravity and give us a positive time. Because if there is such a thing as negative time, and you know about it, you don't need to be in Physics B. So if you plug all that into your calculator, you're going to get 0.78 seconds. 0.78 seconds is the amount of time it takes for our stuntman to fall 3 meters. See what I'm saying about doing this problem backwards? Alright. So now that we know that, let's use that to figure out how far away his horse has to be when he jumps. So in our new picture, our stuntman now has a horse. So in this second part, we're given another number from the problem. We are given the horse's speed, which is 10 meters per second, and this is a constant speed. So now we're going to use this to figure out how far away he has to be. So we know how long it takes the stuntman to fall to the horse. So now that we also know the horse's speed, we can multiply the time it takes for the stuntman to fall times the horse's speed to see how far away the horse is going to have to be. Once again, you plug this into your calculator, or you can do it in your head if you want to. But the distance you get is 7.8 meters, which means the horse has to be 7.8 meters away when the stuntman jumps from the tree. So now that we have these numbers, let's go back to the problem. Like I said in the beginning, we did this backwards. So your first answer is actually B, and your second answer is A. So the horse must be 7.8 meters away when the stuntman makes his move, and the stuntman is in the air for 0.78 seconds. So there's your answer. I hope this was pretty easy to follow.